Okay, this equation has fractions in it, and you can solve the equations with the fractions in there if you want, knock yourself out, but I prefer to get rid of those things. You do have to go by the rule that says what you do to one side of an equation, you must do the same thing to the other. So you're only allowed to use one number. Since one denominator is a 5 and the other denominator is a 6, and 5 times 6 is 30, I'm going with 30. So I am going to multiply both sides of the equation by a 30. And I'm actually going to write this out so you can see exactly what happens. You're going to distribute the 30 to the 1/5 x plus I'm going to distribute the 30 to the 5 equals, and then on the other side I'm going to distribute the 30 to the 1/6 x and I'm going to distribute the 30 to the 3. Seems like my handwriting got bigger as I went from left to right. Now, on the first one, when you take 30 times 1/5, that's 30/5, and 30/5 becomes a 6. And then don't forget the x. 1/5 of 30 is 6, so it's 6x. Plus, here, 30 times 5, that's 150. Over here, 30 times 1/6 is 36ths. But 6 goes into 35 times, so this becomes a 5x minus, and then 30 times 3 is 90. And the fractions are gone. That 30 literally, I jokingly say it sucks the life out of the fractions because technically these 30s are like over ones. I don't need to do the other ones, but when you're multiplying a whole number times a fraction, it's like 30 over 1. You know, you make it look like a fraction. And then the 5 goes into itself once and it cross cancels into the 36 times. So basically you're left with 6 times 1 over 1 times 1, which is 6 over 1, which is 6. And then the same thing happens over here. The 6 goes in itself once, cross cancels into the 35 times. So it's 5 times 1 over 1 times 1, which is 5 over 1, which is 5. So it's gone. All right, and now another color. Now I have to get all the x's on one side and all the non-x's on the other. That's what I like to call them, the non-x's. It's an Aprilism. I made it up. So I'm going to subtract the 5x so that it cancels out on the right. And I'll subtract the 5x on the left to keep it balanced. But in the same breath, since my x's are going to be on the left side of the equal sign, I don't want that 150 over there, so I'm going to get rid of him too. Since it's a plus 150, I'll subtract 150. Because a positive 150 and a negative 150 is 0. It cancels it out. And then I got to do a negative 150 over here as well. And this one works out nice because 6x take away 5x is just 1x, an invisible 1x. And then over here, when I do a negative 90 minus 150, that's a negative 240. And that's your answer. And remember, you can check this. I just grab my calculator since I have such a fancy one and take 1/5 times a negative 240. All right. And that's going to be a negative 48. And negative 48 plus 5 is, my calculator did something weird. There we go. Is a negative 43. So I would get, use my pencil here, I'd get negative 43 on the left. And then on the right, if you take 1/6 times negative 140. That's negative 48. Sorry, negative 40 minus 3 more is also a negative 43. Sorry, I don't have a way to show that on my screen, unless I just wrote it out, but I was doing it on my calculator. But it does check. I plugged and chugged into the original equation, and the left side and the right side both balance to be negative 43s. So the negative 240, sorry, this looks like a 246. That's a 240 is correct.